So in 3.3, we are going to derive an important formula called the slope formula for a line in the XY plane. So okay, so suppose that I had a linear equation and I graphed it, and suppose that the graph of my line looks like this. What I'm going to do is I'm going to choose two unique points on this line. And I'm going to call this point P sub 1. And I will designate this one as being point P2. Okay. The ordered pair address of this first point is going to be X1, Y1. And the ordered pair address of the second point is going to be X sub 2, Y sub 2. Okay. If I vertically project this point down to the x-axis, it will hit the tick mark value of X1. If I vertically project this point down to the x-axis, it will strike the tick mark value of X2. If I take this point and project it horizontally back to the y-axis, it will strike the tick mark value of Y1. And if I project this point horizontally back to the y-axis, it will strike Y2. Do we understand this picture so far here, ladies and gentlemen? Okay, now what I'm going to do here is suppose that we have a person walking along this line from point P1 up to point P2. As this person walks along this line from this point to this point, they're going to experience two changes. They're going to experience a vertical rise, and they're also going to experience a horizontal change or horizontal run. Okay. I'm going to build a right triangle. That is a triangle that has a 90-degree angle on it, or a right angle. Now we can see that we have a triangle here. All right, this is called the amount of rise that we experience. The amount of rise as this person walks up from point P1 to P2 along this line here. They experience so much rise, and as they walk from P1 up to P2, they also experience a certain amount of run. Okay, so they experience some vertical change versus horizontal change as they move from this point to this point along this line here. Specifically, the amount of rise they experience, or the amount of vertical change they experience, is going to be equal to the difference between the y coordinates of these points. So it's going to be Y2 minus Y1. That is going to be the amount of vertical change that the person experiences as they walk along this line here. Y2 minus Y1 is this vertical change. The amount of horizontal change that they experience in walking from P1 to P2 is going to be the difference in the x coordinates. So it'll be X2 minus X1. If you take the ratio of the rise to the run, ladies and gentlemen, you generate what is called the slope of this line. So the slope of our line is going to be equal to the amount of rise versus the amount of run we experience as we move from one point on our line to another point. And that rise is represented by the difference between the y coordinates of the two different points on the line divided by the difference between the x coordinates of the 2 points on the line. You are looking at your slope formula here. Slope. In most textbooks, they use the letter M to represent the slope of a line. And so the slope of this line can be computed by taking the difference between the y coordinates and dividing that by the difference between the x coordinates of the 2 points on the line. This, ladies and gentlemen, is called your slope formula here. It can be used to compute the slope of any line in the XY plane. The slope of a line gives us a measure of how steep the line is in the plane. Okay, how steep it is in the plane. You would also get the same slope if you were to walk from P2 down to P1. So the slope of this line could have just as well have also been computed by taking y1 minus y2 as the rise over the run of x1 minus x2. Both of these would give you the same slope of that line. Okay, same slope. So it doesn't matter which point you call your first and second point to compute the slope. They have to be unique points or different points on the line. Any questions how I developed that slope formula there, ladies and gentlemen? You're not responsible for the derivation of this equation or this formula, but you are responsible to know what it is and how to use it. Okay. All right. So any questions? Well, let's go to our textbook and see if we can use our slope formula to answer some questions now. So 3.4 is entitled the slope of a line. This is actually section 3.4, excuse me. 3.5 is the slope intercept form. All right, so the slope of a line here. Another thing, ladies and gentlemen, it's a well-known fact that if you have a line that has this orientation in the XY plane, we call this a falling line, and falling lines always have a negative slope. So the slope of a line that looks like this in our XY plane will always have a negative slope. Horizontal lines are lines that always have a slope equal to 0. So the slope of a horizontal line is always 0. And this line on the right here, right side here, is called a rising line. And rising lines always have positive slopes. Okay, so just by looking at how your line is oriented in the plane, you can determine whether its slope is negative, 0, or positive. By the way, how about a vertical line? What would be the slope of a vertical line? Well, a line that's vertical in the XY plane a vertical line in the XY plane, we would say the slope is undefined. So vertical lines always have undefined slopes. Undefined. The reason why a vertical line has an undefined slope is because for any two different points on the line, the x coordinates are the same, but the y coordinates are different. So if the x coordinates are the same, that means our slope ratio will have 0 in the denominator. And anything divided by 0 is what?
Zero.
No, what's anything divided by 0? Not 0. You divide 2 divided by
Undefined.
I didn't say 0 divided by some number. I said a number divided by 0. It's undefined. So vertical lines have undefined slopes because with vertical lines, as you move from one point to another point on them, there is no horizontal change. It's all vertical change. And that's why there is no horizontal change. There is no run for vertical lines. And that's why the denominator of the slope formula is 0. And anything divided by 0 is undefined. So vertical lines always have undefined slopes. Horizontal lines always have 0 slopes. And the reason why a horizontal line always has a 0 slope is because with horizontal lines, you have nothing but run. You don't have any rise as you move from one point to another point on a horizontal line. So the numerator is 0. The rise is 0. All you have is run. So 0 divided by any non-zero real number is 0. That's why horizontal lines have slopes of 0. Okay. All right. Let's go to our book now. See if we can start digging into some problems here. You're always welcome to look at the examples in your textbook. And I would recommend that you probably do that. It only helps solidify what it is I discuss in class. Okay. All right, so let's just dive right into some problems. For these problems 1 through 18, it says find the slope of the line through the following pairs of points, then plot each pair of points, draw a line through them, and indicate the rise and run in the graph in the same manner shown in examples 1 and 2. So we're going to try a problem here, and of course you should be using graphing paper, that is a given. So I will try to entertain problem number 2 here. Okay. So let's look at number 2. They give you 2 points that a line contains, or 2 points that are on a line, and they want you to find the slope of the line, or they want you to compute the slope. And so how are we going to do that? Well, we're going to have to, name our points in some manner here. It does not matter which point you call your first and your second point. I'll designate this the 3,1 as being my first point, x1, y1. And I'll call this 5,4 my second point, which is to say x2, y2. So therefore, to compute the slope of our line, we use our slope formula, which is y2 minus y1 over x2 minus x1. Now we just have to substitute the values into our slope formula. So what drops in for y2? What am I going to put? 4, right? Because I'm calling this point my second point. So y2, its y coordinate is 4. So 4 minus, what's y1? Y1 will be what? 1. X sub 2, what's x2? 5. Minus what's x1? 3. Now what's 4 minus 1? 3. 5 minus 3 is 2. And that would be the slope of this line, 3/2. The slope gives us a measure of how much rise we experience versus how much run we experience as we move from one point on a line to another point. So to now appreciate this slope geometrically, we're going to plot those points in the XY plane. Some graphing paper obviously is nice. So I'm going to plot the points 3, 1, and 5, 4. So we start at the origin. And to plot 3, 1, I move 3 to the right on the x-axis, 1, 2, 3, and then I move up 1 unit parallel to the y-axis. So there's 3, 1 right there. That's the point 3, 1. Now to plot the point 5, 4, we start at the origin. We move 5 to the right on the x-axis, 1, 2, 3, 4, 5, then up 4. 1, 2, 3, 4. There's the point 5, 4. We're going to take a ruler. We're going to put a line through these points. And you have the graph of the line that contains those 2 points. That would be its graph. Now what they want you to do is they want you to illustrate the slope by indicating the amount of rise and run. So it does not matter which point you start with. We could start at this point and walk up to this point, or we can start at this point and walk down to this point. It doesn't matter which way you go along the line. I'm going to start at this point and walk up to this point. So if I walk up the line this way, how much rise do I experience? Well, the amount of rise I experience is going to be up 1, 2, 3. So I have a rise of positive 3. Notice my rise is moving in the positive y direction. That's why it's a positive 3. The amount of run I experience in moving from this point to this point along this line is going to be to the right. How many units of run? Looks like 2 positive units of run. This is the amount of run I experience in moving from this point to this point. For that reason, we say the slope of this line is equal to the ratio of rise over run. which is going to be 3 halves. So that would be the slope of our line, 3 halves, 3/2. Questions how I determine the slope graphically?
Can you put your triangle the other way?
Yes, you could. For instance, you could have gone that way. Your rise would still be what, 3 units of rise? 3 units of rise. And then your run would be 2 units plus 2 units, 3/2. So however you want to put your triangle. 3 units of rise, 2 units of run, 3 units of rise to 2 units of run, okay? Questions how we determine that slope both mathematically, using our slope formula, and then graphically. Now, again, it doesn't matter which way you move along this line, whether you move from 0.31 up to 5.4, or if you walk from 5.4 down to 3.1. What if you did walk from 5.4 down to 3.1? Would you get the same slope of 3 halves? And the answer is absolutely yes. So, so suppose that we, wanted to move along this line from, instead of 3.1 to 5.4, what if we wanted to move along this line from 5.4 down to 3.1? Well, would we get the same slope if we went this way? The answer is yes, because the rise now is going to be not +3, but the rise now would be -3. That would be the rise, because we're moving from this point down to this point. So the rise would be in the negative y direction, -3. But the run, since we're moving from this point to this point, the run is going to be not +2 anymore, but the run is going to be -2, because you're moving in the negative x direction to the left. So the slope, again, is ratio of rise to run, and it would be -3 to -2, which is the same thing as +3 halves. And so, ladies and gentlemen, you get the same slope, whether you walk from 3.1 up to 5.4 or 5.4 down to 3.1. Same slope is computed. Does that make sense? Same slope. So instead of calling this point your first point and this your second point, what if we had these switched around? What if we called this point our second point, x2, y2, and this one our first point, x1, y1? Would we crank out the same slope? The answer is absolutely yes. The slope is equal to y2 minus y1 over x2 minus x1. Y2 now would be what? What would y2 be now? It would be 1. Y1 would be 4. X2 is going to be 3 and x1 is going to be 5. So the slope of this line is going to be -3 divided by -2, which a negative over a negative, ladies and gentlemen, is just as equivalent to saying that it's positive. So you still get the same slope. So it doesn't matter which point you call the first one and which point you call the second one. It doesn't matter on the line in the XY plane, whether you move from this point up to this point or walk along the line from this point down to this point. You're going to get the same slope in all cases. Does that make sense there? What kind of a line is this? Is this a rising line, a falling line, vertical line, or horizontal line? What kind of a line is this here? As we move from left to right, notice we are rising on
Rising,
and rising lines always have what kind of slopes?
positive,
Yep, so this is a rising line. So the slope is positive, and that's why its slope is +3 halves. Okay. All right, I don't want you to confuse slope with ordered pairs, ladies and gentlemen. Some students say the slope is the ordered pair 3, 2. That is entirely wrong. The slope has nothing to do with ordered pairs. per se. It's not a point on the line. You don't see the 0.32 on this line. 3.2 is not on this line because slope is not a point. It's not an ordered pair. It just gives you the measure of, it gives you a ratio as to the amount of rise versus amount of run you experience as you move from one point to another point on this line. But the slope itself is not a point on the line, okay? Any questions so far about the slope of a line? Now, you're gonna have to be careful computing the slope of a line, especially when you have a bunch of negatives present. For instance, number one, like number 12, you're gonna have to be more careful because you got minus or negatives here. So let's see if we can compute the slope for 12. They give us 2 points on a line, 2, -4. And the other point is 3, -1. And they want you to find the slope of the line that contains these 2 points. It does not matter which one you call your first and second point, totally arbitrary. Maybe we'll call maybe this one our first point, and maybe we'll designate this as being our second point. Slope of this line can now be computed as y2 minus y1 divided by x2 minus x1. Y2 takes on the value of -1. Subtract y1, which is -4. X2 is 3 minus x1 is 2. So this is going to be the slope of our line. -1 subtract a -4 is -1 plus 4. 3 minus 2 is 1. And so we have 3 over 1. Or later on, we would say the slope of this line is just what? Just 3. So the slope of that line is going to be 3 or 3 over 1. That's saying for every 3 units of rise, you experience 1 unit of run. All right, so if we plotted these points, 2, -4, 2 to the right, and then down 4, -1, 2, 3, 4. There's 2, -4. And plotting the point 3, -1, 3 to the right, down 1. There's 3, -1. Put a line through these points and you have the graph of that linear equation that has a slope of 3 over 1. So if you were to walk from this point up to this point here, you would experience how much rise? You would experience 1, 2, 3 units of rise. And how many units of run? Plus 1 unit of run. And that's why the slope of this line is 3 over 1. 3 units of rise per 1 unit of run. So the slope of that line is 3. It is a rising line. That's why its slope is definitely a positive. So that makes sense. Suppose I had these points switched around. Suppose this was my second point and this was my first point. They don't matter. You're going to get the same slope either way. So if this was my second point and this is my first point, then the rise would be -4 subtract a -1. And the run would be 2 subtract 3. So we're going to have -4 minus a -1 is -4 plus 1, which is going to be -3. 2 minus 3 is -1. Ladies and gentlemen, we get the same slope as 3. So again, it doesn't matter which point you call your first and second point. And it also doesn't matter which way you walk along the line, from this point up to this point or this point down to this point. So if we walk down to this point, our rise now would be -3. And our run now would be -1. Going down in the y direction, negative y direction, and then to the left is the negative x direction. -3 over -1. -3 over -1 is still known as 3. Same slope. So, question how we're computing the slope of a line here so far. All right. All right, so let's look at number 13 here. Okay, well, I'm going to look at number 16 instead. You look at number 16, what coordinates are the same for number 16?
The x coordinates.
And because the x coordinates are the same, are these points going to lie on a horizontal or vertical line? Horizontal or vertical line? What do you think? X coordinates are the same. Plotting these points, -2, 0 is 2 to the left, right there. -2, 0. -2, 5, 2 to the left, now up 5. 1, 2, 3, 4, 5. It looks like these points lie on what kind of a line?
Vertical.
It's a vertical line. Okay. And what's the slope of a vertical line, ladies and gentlemen? Do you remember? Slope of a vertical line.
0.
Not 0. That's the slope of a horizontal line. Well, let's find out. Let's call this point x1, y1, and let's call this one x2, y2. Using our slope formula, which is y2 minus y1 over x2 minus x1. And for y2, we substitute 5 minus y1 takes on the value of 0. x2 is -2 minus x1 is -2. So we're going to have 5 over what's -2 subtract a -2. That's -2 plus 2, which means the denominator is what? 0. What's 5 divided by 0? Not 0. Undefined. So vertical lines have undefined slopes, ladies and gentlemen. The slope of that vertical line is undefined. When you're moving from one point to another point on a vertical line, you have nothing but rise. You don't have any run. There's no run, no light, no left to right or right to left. It's all up or down, all rise. And that's why there is no run. That's why the denominator of the slope formula is 0. There's no run, there's 0 run. That's why the slope of a vertical line is undefined. All right, classwork number 1, problem number 15. I want you to compute the slope of that line. Number 15, I want you to compute the slope of the line, and then I want you to plot those points and then determine the slope of the line graphically also by indicating the amount of rise versus run. So problem 15 is classwork number 1. See if you can
Can I
do
see
that.
that last problem again?
Hold on a second. Vertical lines have undefined slopes. Is that good?
Thank you.
All right, classwork number 1. Compute the slope mathematically, then plot the points, put a line through them, and compute the slope geometrically. Number 15. All right, what kind of line contains those 2 points?
A horizontal line,
And what's the slope of a horizontal line?
undefined.
Not undefined. Vertical lines have undefined slopes. Horizontal lines have 0 slope.
I got 0/3.
Yep, which is 0. That's defined. 0 is a defined real number.
Oh, okay,
You can't have 3 divided by 0.
right.
Yeah, so horizontal lines have 0 slope. Is that what we're all getting here for that one? And it doesn't matter which point you call your first or second point, you're going to crank out 0 slope either way. So that is classwork number 1. Okay. All right. Back to the textbook here. Now here they're giving you the graph of a line and they're giving you 2 points on the line and they want you to compute the slope of the line. Now you can compute the slope one of 2 ways. You can do it mathematically or you can do it geometrically or graphically. Like if you look at problem number 20, they give you 2 points that this line contains or passes through, namely 0, 4, 2, 0. And with that information, they want you to find the slope of that line. So we got 2 points, 2, 0, and we have the point 0, 4. And with that information, we should be able to determine the slope of this line. Now, is this a rising line or falling line? Rising or falling? Not a rising or falling line. Falling line, and therefore its slope better be what? Positive or negative?
Negative.
It's going to be a negative slope when we get done computing it. So we have the point 0, 4 and we have the point 2, 0. To determine the slope, you can do this visually or graphically if you want. If you walk from 0, 4 down to, let's say, 2, 0 along this line, or if you move from 2, 0 up to 0, 4, doesn't matter which way you go. I'm going to go from 0, 4 down to 2, 0. If I do that, then the amount of rise I'm going to have is going to be in the negative y direction. It's going to be -1, -2, -3, -4. So my amount of rise is -4. My run is going to be in the positive x direction, which is going to be +1, +2. Hence, later on, the slope of this line is rise over run, the ratio of rise to the run, which is -4/2. So the slope of this line is -4/2. That's the slope of my line, -4/2. If you move from this point up to this point, from 2, 0 up to 0, 4, you're going to get the same slope. Your rise in this case will now be +4 units of rise. But your run now is going to be in the negative x direction. It's going to be -2 units of run. Same slope. 4/-2 is equivalent to -4/+2. Those are equivalent to each other. So it doesn't matter which way you go up or down this line, you're going to compute the same slope. If you do this problem mathematically, you have to choose 2 points on your line, 0, 4. Maybe you could call that your point x1, y1, and then the point 2, 0, which is called your point x2, y2. The slope of this line is the difference between the y coordinates divided by the difference between the x coordinates. So it's going to be y2, which is 0, minus y1, which is 4, divided by x2, which is 2, minus x1, which is 0. You get -4. You get a slope of -4/2. And there you go. That's computing the slope mathematically. Same slope. So that slope is indeed negative. It has to be. It's a falling line. By the way, what kind of an intercept is 2, 0? 2, 0 is a what intercept of this line? What kind of an x-intercept? What's 0, 4?
The Y.
The y-intercept, correct? All right. We talked about intercepts last week. All right. Now in these problems, they're going to give you two pieces of information about a line. They're going to give you the line slope and also a point that sits on the line. And with that information, they want you then to graph this linear equation. Ladies and gentlemen, up to this point, we've seen two ways to graph linear equations, table method and the XY intercept method. There's another way we can graph linear equations. If we know a point on the line and we know the slope of the linear equation, that's enough to graph the linear equation. So let me choose a problem here and show you how we can do that. So I will choose problem number 28. They give you the slope of a line is 4/3, and they indicate the line is to contain the point -2, 1. Knowing that information, we should be able to graph that line. Let's show you how to do that. So for number 28, they give us the point on the line is -2, 1. They also indicate that the slope of this line is 4/3. Let's show you now how to graph that line. All you gotta do is plot the point -2, 1, start at the origin, 2 to the left and then up 1. There's -2, 1 in the second quadrant. Now the slope is 4/3. So that means if I go from this point to any other point, I would experience 4 units of rise versus +3 units of run. So that should be enough information to plot another point on this line. If I start at the point -2, 1 right here, okay, at -2, 1, if I go up 4 units, 4 positive units of rise, 1, 2, 3, 4, 4. So I go up 4 units, 1, 2, 3, 4, 4 units of rise. I have 3 units of run. So now I got to go 3 positive units to the right. 1, 2, 3 units of run. There should be another point on my line, which is right there, ladies and gentlemen. Up 4 to the right 3. +4 over +3 is the slope of this line. There's another point on my line. What's the ordered pair address of this point? What's the coordinates of this point? What's its x coordinate? 1. What's its y coordinate? 5. I could have started at this point and I could have gone the other way, ladies and gentlemen. Instead of saying the slope is 4/3, I could have said the slope is -4/3. Still the same slope. I could have started at -2, 1 and gone down 4 units and to the left 3 units. Down 4. -1, 2, 3, 4. There's a rise of -4. And then I could got to go 3 to the left now. The negative x direction. -1, 2, 3, -3. Plot another point on our line right there. There's another point on your line. What would be its ordered pair address? What's the x coordinate of this point? -5. What's the y coordinate? -3. Take a ruler, put a line through these points, and you have the graph of that linear equation. Let's put the line right through the points, and we're done. We have graphed that line, ladies and gentlemen. That's your answer. So it's this line that has a slope of 4/3. Notice it's a rising line. That's why its slope is positive. Everybody understand how we did that problem there? That was number 28.
How'd you get that third point again?
I started at my point -2, 1, and I viewed the slope as being -4 over -3 instead of +4 over +3. So if it's -4 over -3, if I start at -2, 1, I go down 4 units. -4, and then to the left, -3 units. Plot another point. So whether you go down 4 units and to the left 3 units, or if you start at -2, 1 and go up 4 units and to the right 3 units, it doesn't matter. You're going to still land on the same line because 4/3 is equal to -4 divided by -3. Equivalent. Any other questions about that problem? How many points could I plot on my line by doing this? Up 4 to the right 3. Up 4 to the right 3, up 4 to the right 3, up 4 to the right 3, up 4 to the right 3. I could do that to the end of time. Do you agree, ladies and gentlemen? Or I could continue to go down what? From this point, I could go down 4 more units. -1, -2, -3, -4. And then 3 to the left again. -1, 2, 3. Another point on my line. Another point on my line. You could do that indefinitely. Whether you go up 4 to the right 3 or down 4 to the left 3, ladies and gentlemen, you're going to keep plotting points on the same line because that's the slope of the line, 4/3 or -4 over -3. Kind of looks like these are what in our everyday lives? Kind of looks like these are steps. Do you agree? Steps you would climb. Do steps have slope to them, ladies and gentlemen? Steps. Do they have slope?
Yes.
You bet they have slope. They have so much rise versus what? So much run. Do you agree? So much rise. So much rise versus so much run. So much rise versus so much run. Steps have slopes to them. Roofs of houses have slopes to them. You agree? If this, ladies and gentlemen, is 10 feet from here to here, from one side of the house to another end of the house, and let's say the height of the roof is 5 feet, what would be the slope of this roof? What's the slope of this roof? Rise over run, do you agree? So it'd be 5 units of rise for how much units of run? Well, assuming that this is a perpendicular bisector of this, ladies and gentlemen, if this is 10 feet, this would then be how many feet? If I divide 10 by 2. This would also be 5 feet, and this would be 5 feet. So for every 5 units I go up, I go over what? 5 feet. So 5 feet of rise versus 5 feet of run. So what's the slope of this roof? 5 feet of rise per 5 feet of run. The slope would be what? 1, correct? 1 or 1/1. That would be the slope of that roof. So roofs have slope to them. So much rise versus run. Roads have slope to them, ladies and gentlemen. Roads. Roads have slope. Do you agree? So much rise versus so much what? Run. Gives you the slope of a road. Although in trucking circles, they don't call it the slope of a road. They call it the grade. The grade of a road, ladies and gentlemen. The grade is slope. Same thing as slope. Rise versus run. So truckers have to beware when they see a sign in mountainous areas that says steep grade ahead. Steep grade ahead means you have to maybe shift down in low gear so you don't lose your load. Do you agree? You don't want to lose your truck. Have a runaway. Trains have to deal with grades too as they're pulling boxcars up in the mountainous regions, up steep inclines. Grades. In the roofing industry, they don't call the slope slope. They call it the pitch of the roof. The pitch. Pitch is the same thing as slope. No difference. Okay. Ready? Slope. If you do downhill skiing, oftentimes you say, I'm going to hit the slopes this weekend. That means you're going to go downhill skiing. But to do downhill skiing, you need some sort of a slope so that gravity can help you go down the hill, correct? All right. So classwork number 2, ladies and gentlemen. Problem number 30 here. They give you the slope of a line and they give you a point on the line. I want you to, using that point and that slope, I want you to graph that line. Go ahead, number 30. I want you to graph that line that has a slope of -3/5 and contains the point -3/1. Now, the slope, they say, is -3/5. Ladies and gentlemen, it doesn't matter if you attach the negative sign to the numerator or if you attach the negative sign to the denominator. Same slope. So whether you want to think of going down 3 units into the right 5 units or going up 3 units into the left 5 units, doesn't matter. You'll have the same slope. You'll be plotting points on the same line. So see if you can do that problem there. So classwork number 2 is going to be problem number 30. Go ahead and try that one, number 30. Does your line look like this? Start at the point, you plot the point -3, -1. To plot another point on this line, you can view the slope as either -3/5 or 3/-5, doesn't matter. If you view it as being -3/5, that means you got to go down 3 units and then 5 to the right, plot another point. Down 3 units, 5 to the right, plot another point. Or maybe you want to look at the slope as being positive 3/-5, in which case you start at this point, you go up 3 units, then 5 to the left, plot a point. At any rate, did anybody get that line graph correctly? Anybody?
Yeah.
All right, so is this making some sort of sense with this slope business of a line? Notice this is a falling line, and that's why its slope is negative. It makes sense, a falling line. Okay. So another way to graph a line is if we know a point on the line and its slope, that should be more than enough to graph any number of other points on that line, and then to graph the line. Okay. Now, there's one other thing in here. Anybody tell me what parallel lines are? What are parallel lines? If two lines are parallel, what does that mean?
They're like side by side.
Okay. Do parallel lines intersect anywhere?
No.
Parallel lines never intersect each other. They never cross each other. Never intersect. And because parallel lines never intersect each other, that means because they never intersect each other, that means their slopes have to be the what? What's the relationship between slopes of parallel lines? So the slopes must be what to each other? The slopes must be equal to each other. Parallel lines have equal slopes. They have to, because if they don't, that means the slant of one line is going to be slightly different than another line. And if the slant's slightly different from one line to the next, eventually they're going to what? They're going to cross each other. Do you agree? Parallel lines must have equal slopes. So if the slope of this line here is M1 and the slope of this line here is M2, it must be true that M1 is equal to M2. The slopes must be equivalent to each other. So ladies and gentlemen, if the slope of line 1, which is M1, is 2/3, what's the slope of line 2, M2? What does it have to be?
2/3.
It also has to be 2/3 because parallel lines have equal slopes. It makes sense. They have to have exactly the same slant to themselves in the XY plane. What are perpendicular lines? Perpendicular lines.
Lines that cross.
Yep, lines that cross, but there's a lot of lines that cross. These two
Is it
lines.
at a 90-degree angle?
Yeah, these two lines cross, but they're not perpendicular. Perpendicular lines have to intersect at right angles to each other. So they intersect at right angles. And to say that they intersect at right angles is to say that they form 90-degree angles to each other. So we would say that these two lines are perpendicular to each other if that's a 90-degree angle. See that? These two lines are perpendicular because this symbol means that from here to here is a 90-degree angle. It's called a right angle. So if this is 90 degrees, this must be what? 90 degrees. This is 90 degrees. This is 90 degrees. Those are perpendicular lines. What's the relationship between the slopes of perpendicular lines? If the slope of this horizontal line is M1, the slope of this line is M2, what must be the slopes of perpendicular lines? Well, perpendicular lines are negative reciprocals of each other. So it's a well-known fact that perpendicular lines are negative reciprocals of each other. A negative reciprocal means two things. First, you take the negative of the slope and then you reciprocate it. Or you take the reciprocal first, then attach the negative sign to it. So perpendicular lines have negative reciprocal slopes. So if this line here, let's say this line here has a slope of 2/3. What then, ladies and gentlemen, would have to be the slope of this perpendicular line? What would have to be the slope of this perpendicular line? What's the negative reciprocal of 2/3?
-2/3.
Well, it's got to be the negative, but it's the negative reciprocal. What's the reciprocal of 2/3?
Oh, 3/2.
3/2. So the slope of this perpendicular line would have to be negative 3/2. These two lines we would say would be perpendicular because their slopes are negative reciprocals of each other. Okay. Got to be negative reciprocals. So if the slope of this line here is negative 1/5, what's the slope of its perpendicular line? What would have to be the slope of this perpendicular line? If the slope of this line is negative 1/5, what's the slope of this one?
+5 or 5.
Positive 5/1. You're correct. Or positive 5. So perpendicular lines have negative slopes. All right. So for problem 48 here, if a line has a slope that is given, state the slope of a line that is A, parallel to this line, B, perpendicular to this line. What would have to be the slope of a line that's parallel to this line with the slope of negative 3/2?
-3/2.
Negative 3/2. If the line is to be perpendicular to this line, what would its slope have to be?
2/3.
Positive 2/3. Ladies and gentlemen, problem number 53. If the slope of a line is 0, what would be its reciprocal? What would be the line's slope if it's perpendicular to this line?
-0.
Well, not negative 0. You got to take the reciprocal of it.
0.
So if a line has 0 slope, that means it's a what? Horizontal line, correct? So what kind of a line is perpendicular to a horizontal line? A vertical line? And if the slope of a horizontal line is 0 or 0/1, that's another way of saying 0, 0 divided by 1. What, ladies and gentlemen, would be the slope of the vertical line? I'll call this M1. What would be the slope of this vertical line? What's the negative reciprocal of 0/1? It would be negative 1 over what? 0? But negative 1 over 0 is called what? What's anything divided by 0?
0.
Undefined. Anything divided by 0 is undefined. This slope is 0 here. This is defined. This is undefined. 0 divided by 1 is defined to be 0. 1 divided by 0 is undefined. What kind of lines have undefined slopes? What kind of a line is this? Well, if this is horizontal, this must be what?
Vertical.
Yeah, it has to be a vertical line. And that's why its slope is undefined. Okay. Okay. So parallel lines have the same slope, perpendicular lines have equal slopes. I said that wrong. Parallel lines have equal slopes, perpendicular lines have negative reciprocal slopes, correct? That's what I should be saying. All right. Well, let's put that section to rest now, ladies and gentlemen. That's the end of section 3.4. 3.5 is entitled slope intercept form. We're going to show you another way, ladies and gentlemen, to graph a linear equation in the XY plane. So far, we've seen how many different methods for graphing a linear equation. We've seen the table method. That's where we compute ordered pair solutions, plot them, put a line through them. We've seen the XY what? Intercept method last week. And today we've seen another method. If we know the slope of a line and a point on the line, that's enough to graph the line. Ladies and gentlemen, there's another way to graph a linear equation we're going to learn now in this next section. It's called the slope intercept form method. Slope intercept form method. So by the time we get done with this last section here, we'll have added another way to graph a linear equation. Slope intercept form. If this is a definition to open up this new section here, 5.4. Not 5.4, 3.5. If a linear equation, is solved for y and in the form of y equals mx plus b form, then it's in what is called slope intercept form. And we call this slope intercept form, ladies and gentlemen, because we can read off two key pieces of information about the line. We can read off the what of the line. What does M represent? The what of the line. It's what?
Slope.
Slope. M is the slope. So just by looking at the equation, we can read off the slope of the line. No calculation necessary. And we can also read off this number B, which is called the y-intercept of the line. So ladies and gentlemen, we call this slope intercept form. Slope y-intercept form. So when a linear equation is solved for y and in this form, it's in slope intercept form. And the advantages of having a linear equation in slope intercept form are quite evident because we can read off the slope and its y-intercept. Consequently, if we know the y-intercept of a line and its slope, that would be good enough then to write the equation of this line and to also graph the line. Okay. So we're going to talk about the y-intercept, the slope intercept form for a linear equation in section 3.5. All right, so let's just dive right down and see if we can entertain a problem or two here. So problems 1 through 14, and they want you to find the slope and the y-intercept for each of the following equations. Notice all these equations are solved for what variable? Everyone is solved for what variable? They're all solved for what?
Y.
Y. They're all solved for the Y variable, notice. And so every one of these equations, ladies and gentlemen, is in what form? What special form are all these linear equations in? Well, most of them are. Most of them are in what form? What's the name of that form?
Slope intercept.
Slope-intercept form. So problem number 2, they give us a linear equation that says y is equal to negative 4x plus 1. Notice that this equation is in strict slope-intercept form. It is in the form of y equal to mx plus b form. That is called slope-intercept form. And because this equation is in slope-intercept form, we should be able to read off the slope of the line and also its y-intercept. What would be the slope of this line?
4x.
-4/1.
Yeah, it's not x. Don't include the variable. The slope is just the number being multiplied by x. So it's -4. So the slope is -4 or -4 over what? 1? That's the slope of that line. The rise is -4. The run is what? +1. What's the y-intercept? We should be able to read off the y-intercept too. The y-intercept is the ordered pair 0b. What's my number b here, ladies and gentlemen? What's b?
1.
1. So the y-intercept is 0, 1. Or sometimes they just say the y-intercept is equal to 1, but it's understood it's the ordered pair 0, 1. Because remember, a y-intercept always has an x-coordinate of 0, always. Okay? I have a question for you. Knowing the y-intercept and knowing the slope, is that enough information to graph this linear equation if we know its y-intercept and slope?
Yeah.
That's enough. That's all we need. Don't need anything else. We know 0, 1 is the y-intercept, so we know the line must contain this point, 0, 1, right there. We know the slope is -4 over 1, so if I start at my y-intercept, if I go down 4 units, -1, -2, -3, -4, my rise is -4, my run must be +1. +1 to the right. There's another point on my line. We could do this again, down 4, -1, 2, 3, 4, and over 1 to the right. There's another point on my line.
Why you go down instead of to the left?
Well, because my slope I'm using is -4 to -4 over +1. Remember, slope is rise over what? Run. So my rise is -4. We go down 4 units. My run is +1. So we go down 4 units and then we go to the right 1 unit. Down 4 to the right 1, right? Down 4 to the right 1. Down 4, which is -4, to the right 1, which is +1. Or if you want to view the slope instead as being +4 over -1, be my guest. It'll give you the same slope. These are equivalent to each other. So I could have just as well started my y-intercept, which is 0, 1, and I could have gone up 4 units and to the left then 1 unit. Up 4, 1, 2, 3, 4, up 4. Now to the left 1 unit, -1. There's another point on my line. So whether we go up 4 to the left 1 or go down 4 to the right 1, down 4 to the right 1 or up 4 to the left 1, doesn't matter. You'll be plotting points on the same line. Take a ruler, put a line through these points. Notice they all lie on a line, and you have the graph of that linear equation. That was in slope-intercept form, and the equation was -4x plus 1, correct? Notice the slope is indeed negative, and that's why this line is a falling line, because it has a negative slope. Right? Negative slope. So what special form is this linear equation in again? Y equal to mx plus b form. That's called what form? It's called slope-intercept form. All right. All these equations are pretty much in slope-intercept form. Just about every one here. Number 9 is a little bit turned around. They need to flip those terms around and call it negative 2x plus 1/4 to put it in the slope-intercept form. So number 9 is a little out of whack there. They should write the equation as negative 2x plus 1/4 if they want it in strict slope-intercept form for number 9. So the slope of this line is -2 or -2/1. And the y-intercept, we can just read it right off from the equation, would be 1/4. Or it would be the ordered pair of 0, 1/4. That's the y-intercept, that's the slope. Slope-intercept form. Slope, y-intercept form. So this equation is in slope-intercept form. It's in the form of, again, of y equal to mx plus b form. Now that you know the y-intercept and the slope, you should be able to plot the y-intercept and use the slope to plot any other number of other points on it, and then graph that linear equation. Okay. They don't want us to graph these. They just want us to read off the slope and the y-intercept for these things. So I'm going a little bit further with these problems. Number 10, if you rewrite that equation in slope-intercept form, how would it be written? Y should be equal to what?
6x.
6x plus what?
2/5.
Now, if we spin these terms around to put that equation in slope-intercept form, number 10 should be written this way. So what's the slope of this line? What's its slope?
6/1.
Yeah, or 6/1. What's the y-intercept? Where will the line go through the y-axis at?
2/5.
2/5, yeah. Or as an ordered pair, it'll go through the y-axis at this point, 0, 2/5. Positive slope, will this line be a rising line, falling line, horizontal line, or vertical line if you were to take the time to graph it, which we're not going to do, but what kind of line would it be? Positive slope. So if you were to graph this, what kind of line is it going to be? Rising, falling, horizontal, or vertical line? It's got to be this. It would have to be oriented this way. It would have to be a rising line. It's got a positive slope. Okay. All right. Number 14, what's going on with this one? Before number 14, let's do number 12. Y is equal to 4x. Is that equation number 12 in slope-intercept form? Y equals 4x? Well, it is. It's just that the y-intercept happens to be what? What's the y-intercept? 0? 0. So this equation is in slope-intercept form. The slope of the line would be 4, or 4/1, and what would be the y-intercept? 0. It would have to be 0, or it would have to be what ordered pair? 0, 0, which is called the what of the xy plane? The origin. So this line would have to contain the origin. It would have to go through 0, 0, right? The y-intercept, and the slope is 4/1. So to graph that line would be pretty darn simple. The y-intercept is the origin, and the slope is a rise of 4 over a run of 1. So for every 4 units you go up, you'd have to go over 1 positive unit. Plot a point. Do that again, up 4, 1 to the right, plot another point. Or you could view the slope as being -4 over -1. -4 over -1 is the same thing as 4/1. So you could go just as well down 4 and to the left 1, down 4, to the left 1, plot another point, down 4, to the left 1, plot another point. You can see how these points would all lie on a line. Do you agree? And that would be the graph of y equals 4x. And notice that this line is a rising line, and it should be since its slope is positive 4. Slope-intercept form. Now what's up with problem number 14, y equals 7? What's up with that one? Is that in slope-intercept form, number 14? Well, you don't see x anywhere. Technically, it is in slope-intercept form. It's just that the slope is really what? What is the slope? Zero times x is as good as saying that this term's not even there. That's why y is equal to 7. So what's the slope of this line, the slope? What would be the slope of this line?
0 over 1 or
Yeah, or just 0, yeah. And what's the y-intercept?
0.7.
0.7, yeah, right, you are correct. Mhm. So what kind of a graph would y equals 7 be? What kind of a line has a 0 slope? Do you remember?
Undefined.
No, undefined slopes are for vertical lines. This slope is defined. It's called 0. 0 has a place on the number line. 0 is defined.
Is it
1 divided
horizontal?
by 0, this is undefined. That's not 1 divided by 0. This is 0 divided by 1, or 0. What'd you say?
Is it horizontal?
Yeah, horizontal line, and when you go through the y-axis at what number? What do you think? Well, what's the
7.
y-intercept? 7, right? That would be the graph of y equals 7. It's a horizontal line. It goes right to the y-axis at 7. That's its y-intercept. Slope is 0 for horizontal lines. So that equation is in slope-intercept form. Just happens to be a 0-sloped line. That's why its graph is a horizontal line. Same thing here, ladies and gentlemen. If they give you the y-intercept of a line and they give you the slope, there should be enough information to graph the line. All right, now problems 29 through 38, they want you to find the slope and the y-intercept for each of the following equations by writing the equation, first of all, in what form? What form do we got to write these equations in?
Slope-intercept.
Slope-intercept form. Notice these equations are not in slope-intercept form, unlike these up here. These were in slope-intercept form. These are no longer in slope-intercept form. So the first thing we have to do is take it upon ourselves to write them in slope-intercept form by solving them for the variable y. So let's look at problem number 30 here. They give you a linear equation, which is negative 2x plus y is equal to 2. And ladies and gentlemen, they want us to determine the slope and the y-intercept of this linear equation. First step we need to do is solve for what? Got to solve for y to put this in the slope-intercept form. You see, this linear equation is not in slope-intercept form. It happens to be in another form called standard form. AX plus BY is equal to C form. This, ladies and gentlemen, is called standard form for a linear equation. First of all, we have to solve this equation for y to put it into slope-intercept form. So how do we solve for y? Help me. What's that?
Add 2x on both sides.
You are correct. First, we got to add 2x to both sides to bring this 2x over to the right side. So we're going to add 2x to the left, and we also add 2x to the right. The 2x's drop out on the left side to 0, leaving you with y, and that's what we want, y all by itself. So y is equal to 2 plus 2x. But this is still not strict slope-intercept form. It will be when I spin these terms around. So y is equal to 2x plus 2. Ladies and gentlemen, what form is this linear equation in now? It's now in slope-intercept form. So we've gone from standard form to slope-intercept. We've gone from standard form to slope-intercept form. And now that our equation is in slope-intercept form, we can just read off the slope and the y-intercept. What is the slope of this line? What is M?
2.
2. Or 2 over what? Understood. 2 over 1? The slope of that line is 2 over 1. What's my y-intercept? We should be able to read it right off from the equation.
0, 2.
0, 2. That's your y-intercept. So now we know the slope and the y-intercept. Hey, would that be enough information if I wanted to graph this equation, knowing its slope and y-intercept? Should I be able to graph it?
Yeah.
You betcha. We've done one like that. We did a couple like that. So we're done with that problem. They don't want you to graph it, by the way. I'm just saying you could graph it if you wanted to. All right. Let's do another one like that. Let's look at number 38. This equation is in what form? 38. Is that standard form or slope-intercept form, this linear equation?
Standard.
Standard form. We want to first of all get it in the slope-intercept form by solving the equation for the variable y. So how do we solve this equation for y? What's the first move here to solving for y? How do I move this negative 4x term to the right side?
Add 4 to both sides.
Let's add 4x to both sides. Notice the 4x's drop out on the left to 0, leaving you with 5y. And on the right side, I'm going to spin these terms around because we're shooting for slope-intercept form. So I'm going to call it 4x plus 20. How we divide both sides by what to get y by itself?
5.
By 5. Therefore, the left side reduces down to just 1y or y. And looking on the right side here, to get this in the slope-intercept form, I'm going to split this up. I'm going to put the 4x over 5. Plus, I'm going to put the 20 over the 5. Legal to do this. Hence, I have y is equal to, now 4x divided by 5 is the same thing as if I say 4/5 times x. 4/5 times x, or x over 1, is the same thing as 4x divided by 5. What does 20 over 5 reduce down to?
4.
4. Liza, what form is my equation in now? Y go to mx plus b form. Do you agree? It's now in slope-intercept form. So what's the slope of my line? I should be able to read it right off from the equation. What is it?
0, 4.
No, what's my slope of my line?
4.
4/5. 4/5 is the slope. What is the y-intercept?
The 0, 4.
It's just 4 or 0, 4. You are correct. Notice we have a positive slope. So if we were to take the time to plot the y-intercept and use the slope to graph the line, we would expect this line to be a rising line. Do you agree? Since its slope is positive 4/5. Okay. So do you see how we're getting an equation, a linear equation, from standard form into what? Slope-intercept form? See how we're doing this here? Okay, now, ladies and gentlemen, they want us to do the reverse. See, up here, they gave us an equation and wanted us to read off the slope and the y-intercept, but now they're going to have us come in through the back door. They're giving us the slope and the y-intercept of a line or an equation, and they want us to write the equation of that line. We should be able to go backwards, right? Problem number 40. Now they give us a line has a slope of 3/4, and they indicate that the y-intercept b is -2. They want us, using this information, to write the equation of this line. You think I can do that, ladies and gentlemen? Think I can write the equation of this line? I know it's slope and y-intercept, so write the equation of the line. I'm going to use the what? What form is this? What do we call this form?
Slope intercept.
I'm going to use the slope intercept form now to write the equation of my line. So here comes my equation. Y is equal to what drops in for the slope? What did they tell us the slope of the line was?
3/4.
3/4 comes down here and gets substituted in place of m here. So we got y is equal to 3/4 x plus what's my y-intercept? They told me my y-intercept was what?
-2.
-2 drops in for b here. Now, your author's not going to leave it as written as plus a -2. We're just going to say y is equal to 3/4 x what? -2. Ladies and gentlemen, we're done. That's your equation of your line in slope-intercept form. So what they did to recap is they gave us the slope of a line and its y-intercept. They said then write the equation of the line in slope-intercept form. We've done that. We're done with that problem. Pretty easy problem, isn't it? It's not that difficult because they give you the slope and they hand you the y-intercept. Pretty simple then to write the equation of that line. Let's try another one. That was kind of fun. Well, let's see if we can try another one here. How about number 44? They give you the slope of a line is -3/5, and they indicate that the y-intercept of the line is 4. They want us to write the equation of this line. So ladies and gentlemen, knowing the slope and the y-intercept, they want us to write the equation. They don't want us to graph this, notice, although we could, they don't want us to graph this here. They just want us to write the equation in what form? Slope intercept form. They want your final answer to be in. So here we go. Y is equal to what? What drops in for my slope?
-3/5 x.
-3/5 drops in for m. So we got our equation as being y is equal to -3/5 x. Plus what's my y-intercept b?
4.
4 plus 4, done. There's your answer. That is the slope intercept form equation of a line that has this slope and has that y-intercept. They just want you to write the equation line. We have done that. So these really are not that difficult to write the equations of these lines because they give you the slope and the y-intercept. All you got to do is just fit them in where they belong into the slope intercept form, and you got your equation. That's the way all these are going to work. They're all going to work the same way. Now in problem 47 through 50, now it says find the slope and y-intercept for each line, then write the equation of each line, and they want your final answer to be in slope intercept form. So there's problem number 48. What's the first thing we have to do? If we want to write the equation of this line that's graphed on number 48, this red line, we want to write its equation. We're going to need to know the what of the line.
The slope.
We need the slope of the line. How would we determine the slope of this line that's graphed in red? Remember, there's two ways we could determine it. We could determine it by using our slope formula in these 2 points, or we could determine it visually or graphically by walking along this line from one point to another point and determining the amount of rise versus run we experience. I don't care how you compute the slope. I just want you to compute the slope. Anybody want to do this mathematically, compute the slope, or do you want to do it visually? In other words, if I went from the point 0.5 and I walked down to the point 3.0, what kind of rise would I have, ladies and gentlemen, walking from 0.5 down to 3.0 along the line? What would be my rise? Would I be going in the positive or negative y direction for rise?
Negative.
Negative direction. How many units? -1, -2, -5. The rise is -5. The run would have me moving in the positive x direction now. +1, +2, +3. So what's the slope of this line? -5 over what? +3? -5/3 would be your slope. So the slope of that line would be -5/3. If you wanted to use your slope formula and put these points in your slope formula to compute the slope, be my guest. You're going to get the same slope that we got visually. If you wanted to walk from 3.0 up to 0.5 along this line, you could have done that. In that case, you'd have how much units of rise? You'd be moving in the positive y direction now. +1, +2, +3, +4, +5. But then you'd have to move to the left in the negative x direction, -1, -2, -3. So the slope would still be 5 over -3.
I was just gonna ask you, could you do that?
Yeah. Yeah, whether you call it -5 over 3 or +5 over -3, same slope. Isn't that true? Aren't these the same slope, ladies and gentlemen?
Yeah.
Whether you go down 5 units and to the right 3, or you go up 5 units and to the left 3, doesn't matter. You'll have the same slope, same line. Doesn't matter. If you want to even call your slope, put the negative sign outside your fraction. You can do that. All of these are equivalent to each other. Every one of these are the same. They're all the same. Okay. Okay, what else do we need to know? We need to know the slope of the line, but we also have to know it's what? What intercept?
Why?
What is the y-intercept?
0.5.
0.5, or we can just say what? 5, correct? So now we know that our B, which is our y-intercept for this line, is 5. We can write the equation of this line now using our slope-intercept form, y equals mx plus b. We can write our equation, and here's our equation. Y is equal to the slope, which is what? -5/3 times x plus, what's my y-intercept? 5? Ladies and gentlemen, there's your answer. This equation would have that graph in problem number 48. Or if you were to graph this equation, you know what its graph would look like? It would be the graph that's in problem number 48, right there. So the equation of this red line in number 48 is y is equal to -5/3 x plus 5. That's how
I
you
have a question for you.
Mhm.
I'm kind of confused at where the y-intercept is 5.
Okay, because that's where our line intersects the y-axis at. The line goes right through the y-axis at 5 there. You see that?
Okay,
So
yeah.
that's why we call the y-intercept
Okay,
5.
okay.
What's the x-intercept? Where does the line go through the x-axis at?
The 3?
3 would be the x-intercept, correct?
Okay, I see.
All right. How about, those are blurry. How about number 47? What's the y-intercept for this line in number 47 here? The y-intercept would be 3, right? And the x-intercept is what? -1? All right, now down here. Now, ladies and gentlemen, they're making it even tougher for us. They're giving us some point on a line and its slope, and they want us to write the equation of this line, and they want the final answer to be in standard form. They want your final answer to be in standard form. So these problems are going to require a little bit more work here. I'll just choose a problem, you know, I mean, maybe one like, I want to do an odd problem. I don't like any of the evens. So I'm going to do like number 55 here. So they give you 2 pieces of information about this line. And what are the 2 pieces of information? They indicate that the slope of the line is what? For number 55, what's the slope of the line? 3/5. And they also indicate that the line is to contain the point -2,6. That means -2,6 will be a point that sits on the line whose equation we're trying to write. So this is what they give us, the slope of the line and some point on the line. They want us, using that information, they want us to write the equation of this line. Well, ladies and gentlemen, it's not as easy as the problems before, because before they gave us the y-intercept. This is not a y-intercept. This point does not lie on the y-axis. It's not the point of intersection between the graph of this line and the y-axis. So we need to understand that this is not a y-intercept. By the way, if it was a y-intercept, the x-coordinate would have to be what? It would have to be 0. Our x-coordinate is not 0. That's why this is not a y-intercept. It's just some other point that's on our graph, our line. And they want us to write the equation. So how are we going to do that? Well, we're going to use the slope intercept form to help us get started here. Now, ladies and gentlemen, this is just some other point on our line. This is just some point XY now in general. So to write the equation of our line, first of all, we're going to use this point and the slope. We're going to plug the values into the slope intercept form. Then we're going to have to solve for the y-intercept, B. So what's going to drop in for my y variable? Well, that's going to be the y coordinate of the point that they gave us that's on the line. And the y coordinate is what? 6. So 6 is going to drop in for y. The slope m is going to be 3/5. 3/5 becomes m. Or m becomes 3/5. That's what I meant to say. X takes on the x coordinate of the point they give us that lies on the line. So x must be replaced with -2. And now we got to solve this equation for the y-intercept for this line. So we have 6 is equal to, what's 3/5 times -2/1? What's 3/5 times -2/1? Gives you negative what, 6/5? How do I solve for B now? Add 6/5 to both sides of the equation. But what's 6 plus 6/5? Well, that's 6/1 plus 6/5. Common denominator 1 and 5 is 5. So to build 6 up into an equivalent fraction, the denominator of 5, I have to multiply top and bottom of 6/1 by 5. And I'll build it up to 30/5. So 30/5 is another name for 6. So what's 30/5 plus 6/5 now? 36/5. That's your y-intercept. Now we know the y-intercept is 36/5. So ladies and gentlemen, our equation of our line must be y is equal to what? mx plus b. We found b now. So what's the equation of my line? Y is equal to m. What's the slope? What was the slope of the line?
3/5.
So the equation of our line is going to be y equal to 3/5 x plus, what's b? We found b to be what? 36/5, and we're done. This is the equation of your line in what form? That slope intercept form. Oh, but wait a minute. Didn't they want your answer in standard form?
Yeah.
They would. This is slope intercept form, ladies and gentlemen. We still got to go a little further with this problem. We have to get this into standard form, which means we must get both x and y on the same side of our equation. And another thing is they don't want any fractional coefficients in front of x or y, no fractions. So how are we going to get this, which is in slope intercept form, into standard form? Well, very carefully. So to get this into standard form, ladies and gentlemen, we must go further. Boy, these fractions sure are a mess. You know, we could get rid of them if we just multiplied both sides by what? What's the least common denominator? 5 and 5. 5? Let's multiply both sides of our equation by 5. Got to multiply the left side by 5. Got to multiply this by 5. Got to multiply this term by 5. So we got 5y is equal to 15/5x plus 5 times 36/5. What does 15/5 reduce down to? 3. These 5s reduce out, and we're left with 36. One last move to getting this in the standard form is we got to move this 3x over to the left side to join the 5y. How do we move a positive to the other side?
So might subtract it.
We got to minus off 3x from both sides. 5y minus 3x, I'm going to spin it around because I want my equation to be in strict standard form. 3x's drop out on the right, leaving me 36. Ladies and gentlemen, we're done. What form is this? What form is this? You recognize it? What form is that called? There's your equation in standard form. You can see how much work is involved to get it there, correct? So, recap. They gave us the slope of a line. They gave us a point on the line. First, we had to find the y-intercept of this line. This is not a y-intercept. So to do that, we used our slope-intercept form. Put our x coordinate in for the x variable, the y coordinate of the point in for the y variable. The slope was replaced with 3/5. Then we had to solve for the y-intercept b, which we discovered b is 36/5. We then were able to write our equation in slope-intercept form. But your author wanted your answer in standard form. So we had to go from slope-intercept form to standard form. To do that, I wanted to get rid of my fractions first. So I multiplied both sides of my equation by 5 to achieve that or accomplish that. All the fractions dropped. Finally, I moved the 3x over to the left side, and I have my equation in standard form, and we're done. Okay? So the good news is if you didn't get all this, it will be recorded, and you can watch this to your heart's content later on. All righty. So that's how you do a problem like 51 through 58 there, ladies and gentlemen. They're going to give you a point on a line and its slope, and they want you to write the equation of the line. That's what they want you to do. Now, problem 56 is very simple. Why is number 56 a very easy problem? Anybody?
Is that the origin point?
Yeah, notice 0, 0 is the y-intercept. They hand you the y-intercept. And they give you the slope. So number 56 is very easy. It's actually a trivial problem. You don't have to go through and find this y-intercept. They hand it to you. They give you 0, 0 is the y-intercept, and they tell you the slope is -5/2. So armed with that knowledge, we should be able to easily write the equation of our line. So our y-intercept, ladies and gentlemen, is 0. The slope is -5/2, so we can immediately write the equation of this line as y is equal to -5/2 x plus 0. Your equation is y is equal to -5/2 x. That's your equation. That's an easy problem. Now, to put it in standard form, you want to get rid of this fraction by multiplying both sides by 2. Two times -5/2 is going to be -10/2. But -10/2 reduces down to what? -5. Add 5x to both sides. And you get your equation in standard form. So 5x plus 2y is equal to what? 0? That's your equation in standard form. So that was a very easy problem. It's an easy problem because the point they gave you is a y-intercept. It's when it's not a y-intercept that you have to do all that work. Problem 58 is equally easy. Why is it? Why is 58 just as easy?
They give you the slope and the y-intercept.
That's right. The point they give you on the line is not just some ordinary point. It's a special point. It's called the y-intercept. That is the y-intercept of the line. So b is equal to -3. So the equation of that line would be y is equal to 3/4 x minus 3. That's your equation. So that's a pretty easy problem, ladies and gentlemen. Pretty easy problem. Okay. All right. So that concludes this this section here. I think I went over everything